Hello students, let us discuss an Intext question, that is question 10.9 in the page number 307. The question is, identify A, B, C, D, E, R and R1 in the following reaction. So these are the reaction which is given, and in this reaction some of the product was mentioned as A, B, C and so we need to identify these. So let us do this one by one. First one, it is a cyclic compound, and first of all identify what it is. It is a haloalkane plus Mg in the presence of dry ether. So you need to identify this reaction. The first reaction is given in this way. First of all, identify the reactant. What is this one? This one is a haloalkane. We can represent it as by Rx plus Mg magnesium. So that means you need to compare this equation, that is the reaction of haloalkane with magnesium. So reaction of Rx with Mg. Now that is in the presence of dry ether. So at the time what will be getting the product? So when you compare this with the general equation, we get a product that is RMgX. So now you need to apply this general equation with this reaction. So at the time you can find that what is R here? When you identify this one, this is our R. So we can say that in the place of R here in the product side, you need to keep that R, that is a ring. So you have to keep that ring. So we'll get the product, that cyclic ring MgX. X here it is Br. So we got this, that is a product A, which is called as cyclohexyl magnesium bromide. Why cyclohexyl? This is cyclohexyl group, then magnesium, then it is bromide, cyclohexyl magnesium bromide. So we got the product A. Now product B. Product B, that is when we take in the general form RMgX. That is a product A which is formed here, RMgX. When it is undergo hydrolysis, we need to break this bond, one H here, one OH on the side. So you will get RH. RH is a hydrocarbon. Similar one when we do in this case, that is the particular case. What is R here? The R is the cyclohexyl part. So when we break this bond, we'll keep one H here, we'll add one OH here. So what we get? That ring and one hydrogen is attached here. That means now it is not a group, that it is a hydrocarbon, that is called as cyclohexane. That means cyclohexyl is converted into cyclohexane. And here one of the side product, that is MgOHBr. So you can find MgOHBr. So the side product which is formed here, that is because of the breakage of the bond, the side product here one H is added, one OH is added. So we can say Mg, this OH and this Br. So we get MgOHBr. So this is a side product which is formed in this reaction. So in this we need to identify A and B. So we got, this is our A, this is our B. That means A is cyclohexyl magnesium bromide and B is cyclohexane. Next reaction. The next reaction, it is given RBr. What is RBr here? That is a haloalkane plus magnesium, give rise to product C. So you can easily make the product Rx plus Mg, that is RMgX, the general equation. So you can write the product, that is RMg. What is here given? Br. So we need to write RMgBr. That means when the RMgX that is RMgBr. When we do hydrolysis, we got that is HOH. In the place of water, it is D2O. So we need to write here D and OD. So we got the product RD here. So when you compare with the structure, what is our R here? Because D is already there. So what will be the R? This part will be called as the R. So we got the R here. What is R here? The R is, this part is the R. So now we can write this R in the case of C product, that is RMgX. So we can got this product. So instead of writing RMgX, as we got, what is R here? The R is this part. So we'll write R as it is. So RMgX. So that's CH3, CH, CH3, and here is the MgBr. That is a C product. And similarly, because here we got the R, so instead of writing the RBr, what we can write here? That is CH3, CH3, CH3Br. So this is in this way, from the product, this we have identified what is R and we have identified what is C. So this is also one of the reaction. Let us little bit typical. From this we can identify what is the R. Next reaction. Next reaction is given in this way. In this reaction, let we start with from here. R-X with the reaction with magnesium give rise to D. Give rise to D. D, that means it should give a RMgX product. But we need to identify that R dash. We need to identify the R dash here. So that we can be easily understood from this equation. Here R dash X reaction with sodium give rise to this product. So we know that when the alkyl halide treated with sodium, the reaction is called as Wurtz reaction. So Wurtz reaction, there is doubling of alkyl group. So here two part is doubling here. These two part is doubling. That means this one will be R and this one will be R dash, this one will be R dash. So from this we identify what is R dash here. This part is called as R dash. So R dash X can be written as like this. That means this part which we have identified from here and X. But when we do the product, that is the D product as we have told RMg, that is R dash MgX. D product is R dash MgX generally when we are writing. Now what is R here? We have identified the R, that is this part is R. So this part, then MgBr. So what is X here? X is Br. So we need R dash MgX we can write in this way. That is this alkyl part is this part, that is MgBr. Now which on further hydrolysis we give rise to the product E. So this one when we do the hydrolysis, so we'll get this product. So that product will be, so you need to break the bond here and one H on this side, one OH on this side. So we'll get a MgOHBr, that is one of the side product, and the main product will be this. That is CH3, CH3, CH3 and one H will be added. So that is giving rise to water. It gives rise to a hydrocarbon, that is alkane is formed. But in this case, the product which is formed here, that is actually here the tertiary alkyl groups are getting doubled. As we have discussed in the Wurtz reaction fails in the case of tertiary alkyl halides. So we can say that this is the product which is expected, but Wurtz reaction get failed for tertiary alkyl halide. Therefore, the reaction proceed to dehydrohalogenation reaction. That means this product is a mistaken here. This product will not be formed. Instead of this, a dehydrohalogenation reaction takes place. So this is the answer for this question. all of you noted down these question and answer in your notebook without making any mistake. It is one of the quite difficult and important question in the textbook. Thank you everyone.